In our continuation of the exploration of decimals, we're going to today look at the multiplication and division of decimals by powers of 10. Our intention is to be able to multiply a decimal by a power of 10 and to divide a decimal by a power of 10. And we'll know we can do that when we can in fact multiply by a decimal by a power of 10 and surprisingly divide a decimal by a power of 10. Now the key ideas today, we'll go over a few slides, not because they're particularly complicated, it just takes a little bit of explaining. The first idea is just something we need to keep in mind, and that is that every number can be written so that it contains a decimal point, but we usually don't need to do this. And the word integers there means whole numbers. So for example, if we had the number 345 like this, we can show it with a decimal place. There are no decimal values, but we can still show the decimal place. And that can be important later on when we start having to multiply our decimals or divide our decimals to be able to show where a decimal place would actually be. The extra zeros can also be added to the right of the decimal point without changing the value basically infinitely. So if we had a decimal value such as 12.5, we can keep adding decimals to the right of that, and we can keep going as many zeros as we want without affecting the actual value. So this value here, 12.5, is the same as saying 12.5000, and we could go an infinite number of zeros. Again, useful to know so that when we look at how we multiply and divide, that can be useful to have those extra zeros there. So when we do want to multiply by a power of 10, what we basically do, the easiest way to think about it, is that we're going to move the decimal point to the right the same number of places as there are zeros in the multiplier. So for example, if we're going to multiply by 1000, there are three zeros in that number. So we're going to move 3 places to the right. What does that look like? Well, here we go. We have 5.7839 multiplied by 1000. So in that 1000, there are 3 zeros. So what we are going to be doing is taking the decimal place from where it is now and moving it 1, 2, 3 places to the right. So multiplication is always moving the decimal place to the right. So our final answer becomes 5783.9. When we do division by powers of 10, it's the same idea, but this time we move our decimal place to the left. So the same thing, the same number of decimal places as the number of zeros. For this example, here is 100, so it's got 2 zeros, so we're going to move 2 places to the left. So in our number, 2975.6 divided by 100, so there are two zeros in 100, so we're going to take our decimal place from where it is here and move it to the left 2 places. So our final answer becomes 29.756. Let's have some more examples of multiplication. Here we have 2.7419 multiplied by 1000. So what I'd like you to do is to indicate how many zeros that we're going to have. It's as easy as underlining it and maybe even write the number near it as well. Don't confuse yourself that that's now a division. It is in fact just indicating how many zeros. Okay, just like I've actually done on the slide there. Then what you do is you write out the number you have. So this number from this side here. Okay, now notice at the moment I haven't actually really written the decimal place in. I've kind of graded out a bit, because if you wrote it in your workbook, it's very hard to then rub it out. So just kind of important to know where it goes. Before the illustration purposes here, that's where it is, and we need to move 3 places to the right now. So it goes from where it is now, 1, 2, 3 places, and that is where you actually write it in. So our final decimal place goes in at this point here. Okay, so our number becomes 2741.9. If we do a division, same idea, 3179.2 divided by 100. There are 2 zeros here, so I'd like to indicate that. we write out the number we have, so the 31792. Think about where our decimal place is. It's technically here at the moment, but we're going to be moving it 2 places to the left. So we go 1, 2, and at that point we actually draw it in. So our answer becomes equal to 31.792. So notice the things that we're doing for our working out to show in our workbooks. We want to always indicate how many zeros we're either multiplying or dividing by. And I'd like for you to, in this chapter at least, to show how the decimal place is moving, either moving to the left or moving to the right. Okay, so something like these little jump arrows here is a good idea. Now let's have a look at the questions. 4.87 times 100. So this is going to be a multiplication. So we're going to be moving to the right with the decimal place. So we're going to first indicate how many zeros. So we've got 2. Sorry, I'm just going to change to the blue pen again. So what we do is we write out 487. Now remember, we're not going to actually show the decimal place where it is now, but we might want to just put a little indicator to help us remember. So it's going to go from there 1, 2 places. So a decimal place goes in here. Now, technically we have the number 487 now. We don't need to technically show a decimal part at the end. But one thing that we often talk about in maths questions is to keep the answer, unless you're told otherwise, in a similar format to the question. So in the question, we do have 2 decimal places being shown. So I'm going to keep this one to 2 decimal places as well. There is nothing in the question that says show it to 1 decimal place or in its simplest form or anything like that. So I'm going to keep the 2 decimal places minimum that the question had in it. So my final answer is going to be 487.00. Okay, that's how I'd like you to try and show your answer. For the second one, we have 0.34 multiplied by 1000. So again, we've got 0, 3, 4. All right, we've got how many zeros? We've got 4 of them here, 4 zeros to show. So what I'm going to do, I'm going to start by, again, indicating where my decimal place was, just with a little arrow for the moment. I'm going to just chuck 4 zeros on the end here. I don't actually know if I need 4, but it's a safe bet to chuck a few there. And then I'm going to do my actual movement. So it goes from here, 1 spot, 2, 3, 4. So this is where my decimal point will end up. Again, I've got 2 decimal places in my question. So I'm going to keep 2 decimal places. So it actually turns out nicely of where it is. But what I don't need to show anymore is this 0 at the front, because we don't show extra zeros at the front or to the left of a decimal place. So my final answer is going to be 3400. There's the decimal point, and I'm going to keep those extra zeros so that it matches up with my question. Okay, so 3,400, but I'm still going to show those 2 decimal places in this case. And again, really important to understand why. It's because there's nothing in the question itself that says how many decimal places to show. So it's common practice to show it with the same number of decimal places as the question. Question 3, we have some division questions. So here we have 47.2 divided by 10. So first of all, how many zeros? Well, it's 1. So we're going to write 472. This is where the decimal point was, so we'll indicate that with the arrow. We're moving 1 spot to the left, so we're going to go from there to here. We don't need to show any extra zeros anywhere, so we're going to say it's equal to 4.72. Now, we have to show both these decimal places because they've both got numbers in them. Even though the question only showed 1 decimal place, the answer that we have does show 2 because there are actually numbers in both of these. So don't accidentally get confused from what we talked about in question 2 and leave off this second decimal place because you think it should only have 1. There's a number in it, it has to be shown. For the second one here, we've got 0.54 divided by 1000. So how many zeros? There's 3 of them. So we're going to write 054. I'm going to indicate where the decimal place was here, the worst arrow ever drawn. and I'm going to be moving 3 spaces to the left. So I'm going to chuck a few extra zeros in here for a second. So we're going from this point to 1, 2, 3. So my decimal place is going to end up here. Okay, remember you always need to show something to the left-hand side of the decimal. So if this is where our decimal point has ended up, we must show this 0. So our answer is going to be 0.00054. Again, make sure you show all the decimals that you need. Don't just go to 2 decimal places because you think you should always show 2. If there's numbers all the way back here, then you have to do that many decimal places. Okay? Question 4. We've got a combination of multiplication and divisions. And in this case, we just got to be careful because the numbers have a lot more decimal places. So how many zeros in our number? There's 3. So we're going to have 0, 0, 4, 2, 6, 8. This is where the decimal place was. We're going to be moving by 3. So we're going to go 1, 2, 3. So our decimal place will end up here. Okay. Now, we have how many decimal places originally? 1, 2, 3, 4, 5. So ideally, I would like to show some extra decimal places here so we have the same number. So it's going to be equal to, we don't need these zeros because they're at the left-hand side of the decimal now. We're going to have 42.68000. So that this has the same number of decimal places as we had in our question. Again, because there's nothing in the original question that says how many decimal places to show, so we generally show the same number as we had in the specific question that we're doing. So I would like to see 42.68000 in this case. The next one says 2.0043 divided by 1000. So we have 3 zeros here. It's a division, so we're going to be moving the decimal place to the left. So let's write it in 20043. Here is where our decimal place was originally. Show it with the arrow. We're going to be moving to the left. So let's just chuck a few extra zeros here. I usually put the same number as what I'm going to be moving by. Often works out well. So from here, we're going to go 1, 2, 3. So we'll end up with our decimal point here. So again, my answer will actually be 0, because I have to have 1 on the left-hand side, 0.00200043. Now, in the original question, we only had 4 decimal places shown. We obviously have more than 4 here, but again, because each of these spots has an actual value, we have to go all the way back to there. So we have to have the 7 decimal places in this particular case. Question 5. Again, we've got some fairly straightforward ones. So we have 43 multiplied by 1000. Let's, just for argument's sake, show 43 as a decimal. So thinking back to the very start of our key ideas, a whole number, for example 43, can be shown with a decimal value. All right, so we can show that the dot 0, the decimal 0, it's still the same number. If we're now going to multiply by 1000, we need to move it by 3 zeros, so 3 places to the right. So technically it goes from this spot. We'll just chuck a few extra zeros here. And we're going to go from there, we're going to go 1, 2, 3. So it's going to end up here. Okay, so our actual answer is equal to 43,000. Let's say 0.0 for a moment. Okay, but again, like we've been talking about, we often, if it's not told us, if it's not in the actual question, we look at how many decimal places were shown in the original question. In this case, there's actually no decimal places shown, so the preferred option would be not to show this decimal point at all and just have 43,000, so 43,000. For the second one here, we've got 2134 divided by 100. So again, 2134 can be shown with a decimal point. Okay, there are 2 zeros in this value here, and it's a division, so it's going to be going to the left. So we're going to be taking the decimal point from where it is here to the left. So we're going to go 1, 2 spots to here. So our answer is going to be 21.340. Okay. Again, though, there are no decimal places actually shown in the question, but we have to keep the decimal places because there are some numbers here. So we have to keep this one, we have to keep this one, but this 0 we don't need to keep. There's nothing else past it. So we will, in this case, move this to be 21.34, losing this last 0. It's the closest we can get to the number of decimal points in the answer without actually losing any information. So in this particular set of questions, the important part is to remember that both of these whole numbers, this 43 here and this 2134, do in fact have a decimal point. Otherwise you will go, well, how do I move the decimal point? So we can show them with the decimal point, and then we can move as we've been doing for other multiplication and division questions. Now, question 6. Again, we're really just doing the same things, but what we've got here is a set of questions with a mixture of operations. The first one's got a multiplication, addition, and division, and the second one's got two additions and a multiplication and division. All right. So what we want to do is be really careful that we do our order of operations correctly. So think about our BIDMAS or our BODMAS, whichever one you prefer to think of, and make sure we do them. It might help you to put brackets into the question to really make it clear for yourself. So here we have 125 multiplied by 1,000 plus 12 divided by 10. So to help myself be really clear, I'm going to chuck some brackets in. So I know that I have to do this multiplication first because not only is it the highest one of the operations, it's also the furthest to the left-hand side of the equation. So it's really making that the most important operation to do. I know that the second thing I'm going to do is this 12 divided by 10 because that's also a very high operation, being a division, and it's a little bit further down the line though because it happens to be more towards the right of the question. So I've rewritten my equation basically to make it very, very clear. Once I've got the answer of those two brackets, then I'll add those together to get the final answer. So if I now look at those brackets, the first one I've got is 125 multiplied by 1,000. So I'm just going to do this up the top next to question 6 there for a bit of space. So remember, 125 can be shown with the decimal place. How many zeros do we have? We've got 3. So I'm going to be moving to the right. So I'm going to chuck a few extra zeros there. And I'm going to go 1, 2, 3. So my real decimal point ends up there. Okay, so my actual answer, if I continue this, is the first bracket is 1, 2, 5, 0, 0, 0. I'm not going to show this decimal place value anymore because my original question doesn't show any decimals. So I'm using that convention we kept talking about of showing how many decimal places there are in the question unless I'm told specifically to show something else. Now I've still got plus bracket 12 divided by 10. So remember, do one operation at a time. So let's do the second bracket, 12 divided by 10. So again, 12 can be shown with a 0. 10 has 1 0 on it. Okay, so I'm moving one spot to the left because it's a division. So my number's going from here to here. So it actually becomes 1.20. I don't need to show this 0 anymore, but I do have to keep the 2. Even though the question actually has no decimal places, I need the 2 because it's got a real value there. So now what I've got for my question is 125,000 plus 1.2. Now I'm going to do the simple addition, and that's really straightforward. So it's going to be equal to 125,001.2. And that would be my final answer. Working out bracket 1, bracket 2, and then adding them together at the end. For my second question, there's a few things we might need to know. If we look at that, it might not be obvious, but where that 10 bracket is actually multiplication. So when I read this, I've actually say 4 plus 10 times the bracket being 19 divided by 100 plus 7. This spot here, when there's nothing in between it, that's another way mathematically to say multiply. The 10 multiplied by whatever's in this bracket. It's very, very common when we start talking about algebra, but it also works when you've got a number multiplied by something in a bracket. So if it helps you to rewrite it, you can. So you can say it's 4 plus 10 multiplied by 19 divided by 100 plus 7. So if you need to rewrite it to remind yourself that that multiply is actually there, you should do that. So what is it that I need to do? Again, think about my order of operations. First thing I'm going to do is the 19 divided by 100 because that's in the brackets. So that's absolutely first, and it's the most important thing in there. So I'll do the 19 divided by 100, then I'll add the 7 to that answer. Then I'll take the answer of all of that bracket and multiply it by the 10, because that's the next most important operation. And then whatever all of that is, I'll add that to the 4 at the front. So there's a few steps to this one. So I'm going to just come up here for a bit of space. All right, so please don't get this confused with the previous question. So the first part is 19 divided by 100. So how many zeros in 100? It's 2. So I should just chuck a few extra zeros here. Sorry, it's a bit messy now. Remember, 19 actually has a dot 0. We're moving 2, so we go 1, 2. So our actual answer is going to be 0.19. Okay, I don't need to show this 0 at the end anymore because it's moved. So 0.19. So this equation is now 4 plus 10 multiplied by bracket. The 19 divided by 100 I've said is 0.19 plus the 7 still. Because this is in brackets, I still have to do the 0.19 plus 7. So now it's equal to 4 plus 10 multiplied by 0.19 is 7 is pretty obvious. It's 7.19. I can leave the brackets out if I want to. Next step, again, I'm going to come up here for a second. Okay, I've got 10 multiplied by 7.19. So I've got 7.19. There is 1 0 in this 10, so I'm going to be moving one spot to the right. So I go to here, so I end up with 71.9. Okay, so again, just for a bit of space, sorry about this, our equation is now written as equal to 4 plus 71.9. And I think we can see that addition very easily. It's 75.9. So again, there's not anything particularly complicated. It's just carefully going through each step of the equation, following our order of operations, knowing which part to do first, obviously working out each bit of the math properly, putting it back into the equation to end up with our final answer here. Okay? Question 9. Now, question 9 is our worded problem. There's a few steps to this, but again, nothing difficult if you just take it step by step. So first thing, let's read through it and make sure we understand what it's telling us. So it says the canteen sells lollies that are 15 cents each, and Jenny usually buys 10 per day. How much will Jenny spend if she does this for 100 days? And we then need to give our answer in cents and also convert to dollars. So let's first look at the important things that are highlighted even for us. First thing is the lollies are 15 cents. Now, we could leave that as a number 15, but let's convert it into cents. So it's going to end up as a decimal. So 15 cents is the same as saying 0.15 when you talk about dollars and cents. All right, if we put a dollar symbol at the front, that makes sense. Surprisingly enough, pardon the pun. And she buys 10 of those a day. So what we really have is 0.15 multiplied by 10. She gets 10 per day. So if we do that, we've got 1 0 in the multiplication. So we're going to move our decimal place one spot to the right. So we end up with that being 1.5. Again, we should put the dollar sign back in. And because we are now talking about dollars and cents, we do always show two decimal places with dollars and cents. So what we have here is how much she has for one day. $1.50 or 1.50 in one day. Okay, we now want to know for 100 days. So we've got another multiplication here. So if we take our 1.5, right, and we multiply that by 100, we've got the same situation. There are two zeros here. So we're going to go 1.5. There's where the decimal place would have been. We're moving two spots to the right, so we need an extra 0 in there. and that's where our decimal would be. All right, we're still talking about dollars and cents, so let's include the extra 2 zeros, and then let's include the dollar symbol. So what we have now is how much she would spend if she buys the same amount of lollies for 100 days, and that is $150. All right, show the 2 zeros. It's a lot of money. It adds up pretty quickly. We have to remember this last bit of the question. Give your answer in cents and then convert it to dollars. But we've already got the dollars amount here. How do we convert that to cents? So let's think about that. There are $150, and how many cents in a dollar? There is 100. Okay, so if we multiply 150 by 100, that will give us how many cents we have. So again, technically there's a dot zero here, so we want to move it to the right by 2 places. So 150, that's where the dot would be. We'll chuck a few zeros here for argument's sake. Let's go 1, 2, that's where it'll end up. So in the actual cents, we have 15000 cents. So 15,000 cents if you were paying by 1 cent coins, which of course don't exist anymore. So all up, we have all the answers we're looking for, all the bits of the answer anyway. We know how much she spends in a day. We know how much she would spend if she did that every day for 100 days. We know that in a dollar amount here again, and we know that as a cents amount. But this is a worded question, so we have to write a worded answer. So I don't have a lot of room, so I'm going to have to do this over a couple of lines. But we're going to write that Jenny spends $1.50 per day. What should we say? $150 in 100 days, which is 15,000 cents. So something like that answer is what we would be looking for. All of our working out comes down to this answer here, where we've put everything we need to answer the question in words. So there's quite a bit to that question, but none of it's hard. It's just understanding what the question's asking as always, doing each step of it, and then bringing it together in some sort of worded answer. So there's a pretty big section. Again, it's easy. It's not a hard concept, but it does just take some thinking about. It takes some careful moving of decimal places. It is easy to accidentally move a decimal place too far or not enough. So it's really important, at least while we're learning, getting used to it, that you do each step, that you show how the decimal place is moving. It doesn't matter if you have to rewrite the same part 2 or 3 times until you get to your neat answer. The more you show, the more you are clear how the decimal place moves, the more likely you are to get the right answer at the end. As always, thanks for watching. If you're having any trouble, please get in contact.